This is our final lesson, guys. Trigonometric ratios, angles of elevation and depression. That angle's sad because he's an angle of depression. Okay, angles of elevation and depression. An angle of elevation is the angle formed by a horizontal line in an observer's line of sight to an object above the horizontal line. So imagine looking up at a flagpole, a flag on a pole. Your eyes would go up, and that would be the angle of elevation. An angle of depression is the angle formed by a horizontal line in an observer's line of sight to an object below the horizontal line. So imagine you're standing on a balcony and you're looking directly out, and then you look down to the street and you see your friend walking down the street. That would be the angle of depression. You're looking down. So elevation is up, angle is down. Excuse me, depression is down. Oh boy. Anyway. So between two objects with an angle of elevation and an angle of depression, so let's use this as an example. The jet is flying over the ocean, and there's an observer, let's say, on the deck of the battleship, and the observer looks up at the jet. He sees the jet, and it is a 20-degree angle of elevation. The angle of depression would be is congruent to that angle, so that the pilot, let's say, looks down and he sees the observer on the deck. He's at 10,000 feet. And this angle would also be 20 degrees. So angles of depression and angles of elevation are congruent.
Super fun math fact.
Cool, huh? So Eratosthenes, he lived about between 276 and 197 BC. He was a mathematician and astronomer who was born in Cyrene, which is now in Libya. Libya is located in northern Africa on the coast of the Mediterranean. And he used the angle of the elevation of the sun at noon in the cities of Alexandria and Syene, now Egypt, to measure the circumference of the earth. Believe it or not, nobody really believed that the earth was flat before Columbus. They all knew, and this was a couple hundred years before Christ, that the earth was spherical. So that's a myth that somebody came up with, and it's kind of a dumb one. Anyway, if we have two angles of elevation and depression, we could use that to look at two different objects and estimate the distance between those objects. And we can also look at angles from two different positions of observation to the same object, and it can be used to estimate the object's height. So here we have triangle DEF is shown, and we want to find the measure of angle D to the nearest degree and the length of E to the nearest tenth. And we're going to use some trig to do that. So we're going to take and find angle D first of all. So if you remember from the trig video, this is theta, right? When we're looking for that, we don't know what it is, we use theta. So from angle D, theta, this is the opposite, and this is going to be the hypotenuse. And when we plug in O and H into our secret code word, SOHCAHTOA, we know that we are going to use sine. So the sine of theta is equal to 11.2 over 20.1, right? Opposite over hypotenuse. Now, since we are looking for the angle measurement, we want to use the trigonometric inverse of the sine. So the inverse of sine, so we're going to use symbol of -1, and now 11.2 over 20.1 is that ratio. That's what we're going to plug in. That's going to equal theta. So those two switch places then. So we're going to go ahead and use our handy dandy calculator, and we're going to pull up the inverse of the sine, and I'm just going to plug in 11.2 divided by 20.1, and I hit enter, and lo and behold, I got 33.8633. So this is going to be 34 degrees. So we're going to say that the measure of angle D is approximately 34 degrees. Now we want to find e to the nearest 10th. So there's a couple ways we can go about doing this, and we could use trig if we wanted to. And maybe that's why don't we do that? We've done enough Pythagorean theorem that we should be able to manage this. And either way, it should come up to a pretty close answer. So let's go ahead and do that. So if we knew this is angle D is 34 degrees, we could say that we could use the cosine of 34 is equal to E over 20.1. And so the cosine of 34, we can take this and multiply each side by 20.1. So 20.1 cosine of 34 is equal to E. So let's see what we get with this. 20.1 times the cosine of 34. And I hit enter and I get 16.6637. So it's going to be 16.7. So it is 16.7. Let's see what we would have gotten with the Pythagorean theorem. So I got 11 points, so I've got e squared plus 11.2 squared equals 20.1 squared. So e squared, let's do this before we go any further. We'll say 20.1 squared minus 11.2 squared, and I'm just going to take e is equal to the square root of 20.1 squared minus 11.2 squared. So I'm going to plug all that into my handy dandy calculator and just hit the button one time and be done with it. So square root of 20.1 squared minus the square root of 11.2 squared, and I hit enter here, and I got 16.6904. So if I round that, I'm still going to end up, not 16.1, this should have been 16.7 before. There was a mistake there with that. That should have been 16.7 because the prior answer was 16.6637. and this other answer was 16.6904. So we're rounding to the 10th. Either way, we would have gotten E as that value. Okay. To an observer on a cliff 316 meters above sea level, the angle of depression of a ship is 28 degrees. What is the horizontal distance between the ship and the observer? So we have our right angle that comes right down here, and it's right there, 360. And since these two angles, by the way, are congruent, right? Either way, we can do this. I also know that this angle here is congruent to this angle here, right? The angle of elevation is equal to the angle of depression. So this is also 28. So we want to find x. So this is going to be the tangent of 28 is equal to the opposite, which is 360, over the adjacent, which is x. And if you remember me talking about this, we can switch these out right here, right? We can switch these two out. switch these with each other. So x is going to equal 360 divided by the tangent of 28. So, handy dandy calculator time. So, 360 divided by, hit my trig key, hit the tangent button, and I've got 28 degrees as my measurement. I hit enter. Kaboom, 677.062. So we're going to say, we're doing this in meters, so x, let's do it, just round it to the nearest meter, 677 meters. Okay? Let's do one more example. Okay, so an observer on a cliff 1,000 decimeters above sea level sights two ships due east. The angles of depression of the ships are 47 degrees and 32 degrees. Find to the nearest decimeter the distance between the ships. And the best thing we have to do when we start is a drawing. So we can see my terrible drawing here. And so here's some knowledge that we know. We know we are 1,000 decimeters. We'll say this is it right here. Right, or here it is. And we're there. And that's 1,000 decimeters. A decimeter being a tenth of a meter. So that's about 100. That's 100 meters, right? We're 100 meters above the ocean. Okay, so now, because we're talking about an angle of depression, so when we have our sight line here, right? So you're going to have one angle that comes like so and measures like this, and another angle that comes like so and measures like this. So this angle here is 32, and this angle here is 47. Okay, now we can go ahead and set up some trig. So we're going to go with, this is the distance. Now we can keep this in mind that we can measure from here, or we can do this. We can draw our measurement here, and this one's going to be x, excuse me. And we're going to also have this here and here, and the red one will be y. And the difference between x and y is going to be this right here. Okay, so this distance here is going to be y minus x. Okay, so we've got our right angles here, so we're going to do a little bit of trig. So we're going to use, we know that the height to the water here is 100, so we're just going to stay with 100 decimeters. So this is 100 decimeters here, and this is 1,000 decimeters on both of these, right? So we're going to solve for x first. We're going to use 47 degrees. So the tangent of 47 is equal to the opposite, which is 1,000, over the adjacent, which is x. And we're going to switch those out again. So x is going to equal 1,000 divided by the tangent of 47. So we take the handy dandy calculator and we plug this in. So 1,000 divided by the tangent of 47. And we get 932.515. So we're going to go with 933, right? We're going to round it up right now, okay? As soon as we have that distance. So 932.5 becomes 933. So x is equal to 933 decimeters. Okay, let's now do our calculations for y. So, the tangent of 32 is equal to 1,000 over y. So we're going to switch those out again. So y is equal to, I'll put this over here, y is equal to 1,000 divided by tangent of 32. So again, we plug it into the handy dandy calculator, 1,000 divided by tangent 32. And I got 1600.33, so y is equal to just 1600. So how far apart are the ships? Well, we're going to take 1600 minus 933, and our final answer is 667. So the distance between those two ships is 667 decimeters. Which, since most of us are not metrically astute, being Americans, we really don't use metric for distance. So the distance is approximately 218 and 7/8 feet apart. Okay, so we just say, like, maybe we'll just say 219 feet approximately. So that's our final example for this school year. Gentlemen, you completed Honors Geometry 2019-2020. Congratulations.